Everybody, it's Miss Craig again. I hope you're all well and you've enjoyed the beautiful weather this weekend. We are finally in June. Yay! So there's light at the end of the tunnel. So this is our Learn About It video for lesson 1 for the week of June 1st through the 5th, finding the volume of pyramids and cones. So just to remind you, a pyramid is when we have a polygon base and our triangle faces that come up and meet up as a vertex. The pyramids are named by whatever their base is. So a triangular pyramid has a triangle as the base. Rectangular pyramid has a rectangle as the base. Pentagonal pyramid has a pentagon as the base. And a hexagonal has a hexagon as the base. And again, the reason why they are pyramids is because every face of the pyramid is a triangle and they all meet up at that vertex. So a cone really is a pyramid but has a circular base. So when we're talking about our cone, we have a circular base, and I am not an artist, and then the cone kind of wraps around up to a vertex. It's kind of like an upside down ice cream cone. So when we're talking about the volume formulas, when it's a pyramid, we take the area of whatever that base is. So whether it's the triangle formula or rectangle or whatever it is, we multiply it by the height and then we divide it all by 3. So since a cone really is a pyramid with a circular base, when we take that area of the base of a circle, the base area would be pi r squared. Multiply that by the h, divide by 3, and then sometimes the formula gets simplified into 1/3 pi r squared h. So on all of the problems, as you work through them, you would just find the appropriate formula, substitute in the values. So here we have a square pyramid where our edge length of our square is 9 centimeters and our height is 4. We'd start off by filling in the formula. So volume is area of the base times h, all divided by 3. So here the area of our base would be 9 times 9. That would be our base. We're going to multiply that by the height. They tell us our height is 14. And then we would divide that by 3. So if we do all of that math, we would end up with 378 centimeters, because we're measuring centimeters. Against its volume, we say it's centimeters cubed. On the next one, we're practicing volume of a cone. So again, we're going to start with the formula. So our formula would be pi r squared, which is the circular base, times height divided by 3. So if we fill in our values, we'd have our pi. Our radius, it says, is 7, so that would be 7 squared, times our height is 15, divided by 3. So they tell us here to keep our answer in terms of pi and round to the 10th. We'd leave our pi be pi, so we would do our 7 squared times 15 divided by 3, and that would give us 243 pi centimeters cubed. If we round to the nearest tenth, we would use our 3 1400 for pi. We would substitute that in, so we would take our 243 times our 3 1400 for pi, and that would give us 769 7/10 centimeters cubed. So our next one, we're still talking about volume of a cone. So if we are talking about our formula, again, we know volume is equal to pi r squared, which is the area of our circular base times height divided by 3. And now we need to substitute in the values. So we see see that our height is 2. So we know that that height number is 2. We know we have our pi. We know we're dividing by 3. The problem is we need the radius. So when we go to fill in our radius, we have to use our circumference. So they tell us that our circumference is 25 pi. So to get our radius, we know that circumference is equal to 2 pi r. So 25 pi is equal to 2 pi r. Divide both sides by 2 pi. And we would get that 12.5 is equal to r. I'm going to erase this height here for a minute. So we know that our radius is 12.5. That's a really bad one there. Let me fix that. Squared. Now our height, at first I thought it was 2, but I'm sure some of you are yelling at me. It says a height is 2 inches more than twice the radius. So to find our height is equal to 2 more than twice the radius. So if we would do that math, our height would be equal to 27. So in our volume formula, we're now going to substitute in 27. So again, we would do the math. We would take 12.5 squared times 27 divided by 3, and that gives us 1,406 and 25 hundredths pi. And this time we're measuring in inches. It's volume, so it'd be inches cubed. On our next one, we're still working with a cone. So again, we're going to start with our formula. So volume is equal to pi r squared h divided by 3. So we have to find our radius. Well, that's given to us. So we know that it's going to be pi. My radius is 16 squared. Now we have to find our height. So now remember, our height is determined by what that perpendicular height is. We're given that slanted height. So if we imagine this forms a triangle, we can use our Pythagorean theorem to find out that missing height. So for the Pythagorean theorem, we know we would take 16 squared plus whatever that height is squared is equal to 34 squared. So if we would do our math, we would get that our height squared is equal to 900. Take our square root, our height would be equal to 30. So now we can substitute in 30 for the height, divided by 3. Again, we would do our math. 16 squared times 30 divided by 3 would give us 2,560. We still are in terms of pi. And we're measuring in centimeters, so that would be centimeters cubed. So now we're finding the volume, for example 5, of a composite figure. So our composite figure is when we're taking a bunch of little figures and we are putting them together. So if we see we have a cylinder here in the middle, and then we have a cone on the top, and we have a cone on the bottom. We'd have to find the area of each of those and then add those 3 pieces together. So if we are doing the upper cone, my formula for volume, since it's a cone, we would take pi r squared times h divided by 3. So we have our pi. We look at the radius of the upper cone, it's 21 squared, and now we have to multiply it by the height. When we're trying to find the height, from the bottom of the cylinder to the top of the top cone is 35. The cylinder takes up 35 of that. So to figure out the top cone, if we do 70 minus 35, it would also be worth 35. So my height would be 35, and then we would divide it by 3. So if we substitute in all of those values, we do the math, we get 5,145 pi. And again, we're measuring in centimeters cubed for volume. So now we're going to look at the cylinder. So when we look at the cylinder, that was from last week. So if we look at our notes from last week, that would be volume is equal to pi r squared h. We'd have our pi. Radius is still 21 squared. They tell us my height of my cylinder is 35. Multiply that out, we get 15,435 pi, and again, centimeters cubed. So last we have our bottom cone. Our cone here at the bottom. So again, since it's a cone, it's pi r squared h divided by 3. We have our pi. My radius is still 21 squared. My height on this bottom cone, though, is 40 divided by 3. We substitute in all those values, do the math, we get 5,880 pi centimeters cubed. So to find my total area, I would just have to add up all of my composite areas. And if we add them all up, we get 26,460 pi centimeters cubed. So next steps, there is an additional video, and there's some GeoApplets to play with, so you could do those before you go on to the Try It section. I'll have another video there with some of the practice problems. Make sure you always check all your answers. If you're in Ms. Thomas's class, we have that extra activity. Everybody, please take care, stay safe, and we will talk soon. Bye.